Okay. Thank you for being here. We really appreciate you. It's Thursday evening or late afternoon. My name is Jigar Shah. I'm a senior product manager at Palo Alto Networks. With me is Megha, who's also a product manager at Palo Alto Networks. So what we're going to talk about is obviously how do you do protection for exfiltration and security in public clouds, more specifically Azure and Office 365. Before we get going, a quick show of hands. How many of you have heard of Palo Alto Networks? What about PAN? Have you heard of PAN? No. Okay. That's a company joke, because everybody calls our long name. Okay. So, and how many are security admins, network admins, and Office 365 administrators? Okay. Some of you have combined hats, others not. Okay. So this is sort of an intermediate to advanced level in general, so that we will cover a lot of concepts and capabilities that are there. We won't go into the depth of those Azure features specifically. Hopefully you know some of those Azure networking capabilities. If not, talk to us afterwards. And questions are definitely welcome. Okay, so the idea is obviously that this is sort of a familiar picture, right? Your on-prem data center is expanding to the public cloud. You have lots of SaaS services that you're using. And then obviously you've been virtualizing your data center on-prem quite a bit. So I will primarily cover the public cloud side of it, which is the Azure section. Megha's going to talk about how do you secure the SaaS side of it, right? And I think this is sort of a common concept that's already well known, but it's good to always reiterate, right? The common risks or vulnerabilities or breaches come from sort of three big sources. I wouldn't focus on the percentages itself, but at least we know malicious outside are still the #1 vector. Accidental data exposure off late, if you've been following news, is quite a bit more common. Because there's new sets of controls you've got in the public clouds, and it takes a while for everybody to learn what are all those knobs and how do you configure them. And then obviously there's always a malicious insider. There's always a potential vector of problems. So this is again also a very familiar thread if you're familiar with the attack lifecycle. And our contention is that this is the story that we've always understood in on-prem networks, enterprise networks, data centers. We don't think this is too dramatically different in public cloud as well. There is a way people get access to credentials or they get into your networks, public cloud or on-prem, they spread across to find the highest value target, and then they try to exploit it. And obviously, a command control server or some intermediate management or admin place drives those things once they have access to your environment. At least in public clouds, the most common things we've seen is steal data, so essentially reputation damage, disruption of operations. Those are the big things that the attackers are going after. And the other stranger things that we see more often now is that they will try to build a botnet out of that computing resource because they hijacked a VM. Most of the cloud services have really high bandwidth network connectivity to the internet. So it becomes a really nice way to spread your botnets. So earlier in the year or late last year, there was all those IoT-related attacks. Those were kind of similar in that you have this vector of spreading infections quite a bit. So a VM in the cloud is a very nice way to build a botnet, in effect. And then the last ones, which is a little bit more obscure, is free money. If you got a hold of a VM, you could run Bitcoin mining. Like my developers are kind of the smartest guys, but they're also the laziest guys. Like they've created a VM and it's like admin. I'm like, why'd you do that? Oh, well, I was just testing something and I was going to delete it over the weekend. And it's got a public IP and they just leave it up there for somebody to come brute force it, right? So these are things that are on-prem known and they're quite similar in the public cloud. So to prevent those things, the same security fundamentals that you know equally well apply, right? You want visibility because if you can't see it, you don't know what's going on. Once you have visibility, you want to try to enforce control by reducing the attack surface. And I'll talk about what are the controls and knobs you've got to do those things. And then you're preventing known attacks, and then also trying to figure out what are the unknown attacks, and how soon can you turn those unknown things into known things and block them, right? So that's sort of the basic concept, and it's been around for a while. And obviously what an advanced security platform wants to do is, how do you take these concepts and offer actual technical capabilities that provide these, right? So these are some of the things that you have to do to make all these capabilities happen. So on the visibility side, you have to look at all the applications, all the users, all content, all clouds, everywhere, right? And so I'll give you an example, right? So if you're trying to prevent malware from spreading around, that east-west example, how do you do that? Well, you got to first cover all your applications because malware tries to look at all kinds of applications, right? It's not just the web server, it's just not the database, it's not just your custom application, it can be anything. You got to protect that. Obviously now, people have got awareness, SSL, TLS, it's all out there. You got to look at encrypted traffic too, because the attackers are smart too. Once they get into your network, they also build encrypted tunnels. And if you're not looking at encrypted traffic, they're literally hiding in plain sight. You know, SSL is kind of the most common thing you'll see in firewall logs. So you got to look at encrypted traffic. And obviously, you got to cover cloud and all these other places. So, and once you've started looking at those things, unknown threats, you know, kind of your zero-day or patient zero attacks, you have to look at all these things, right? Dynamic network analysis, static analysis, machine learning, all these things that all our researchers are spending time on, you have to do all those things. So this is sort of a quick flavor of what an advanced security platform needs to offer. Now, bringing all that into different environments, how do you achieve that, right? So our approach is this. You want to have consistent security everywhere, on-prem, cloud, every single place, which means that you've got to cover all the clouds and hypervisors in all these platforms. And if you're going to the cloud, you've got to operate with the cloud mantra, right, which is elastic scale out, usually more horizontal than vertical, right, scale out, and then a little bit of scale up if you need. And then finally, things have to be orchestrated, working together with other components. So pretty much everybody has moved to a DevOps model. As DevOps is deploying, you want API integrations, automation, templates, and so on. So those things are very crucial in terms of bringing security in a practical fashion. Okay. So I mentioned that the cloud also has some basic built-in security options. In Azure, those are called network security groups. If you build an Azure VNet where your resources are going to live, this is your data center in the cloud, Azure offers you network security groups and ACLs. So these are core protocol-based technologies that have been around for 20, 30 years. Those are really useful and complementary to what we are doing. They provide a way to reduce the attack surface. So if you've got a web application that's internet-facing, you would just open port 80 and 443 for inbound. But then you've got to decide, like, what do I do for outbound? What do I allow? And then when I have outbound traffic going out, what do I let it go out to, right? You could say outbound is usually two kinds of traffic, right? One is usually updates. Second is it's connecting to some partner system. So if you're running a web e-commerce site, it needs to connect to a financial institution, for example. And for updates, it may go to Linux servers, or it may go to Windows updates servers, things like that. So the basic security capability that the platform provides is good enough for some basic controls, but it's not looking at doing all these advanced capabilities and looking at malware and things like that. So the recommendation is that you should set NSGs and ACLs to restrict certain kinds of traffic. For example, if you've got a management or a bastion set up, make sure only your corporate IPs or organization IPs can connect to those, right? That you don't open to the entire internet. If you want, you'll have fun looking at how many people try to brute force your systems, right? And then whatever is your data plane or your application traffic, that may be open to the internet for inbound, but then you want to make sure that that traffic is only coming in. So if it's a web app, only HTTP traffic should be coming in and not something else that's trying to tunnel over HTTP, right? Okay, so those are sort of the basic capabilities the platform provides, and then we are layering on top and adding more security, right? And essentially, we're trying to bring those additional controls, and I'll show you what those means. So now to actually achieve security beyond what the NSG gives, to do that protection against exfiltration and advanced threats, here's sort of a basic set of ideas that I think you've done this on-prem, and we're extending that same idea, right? So the first thing you're going to do is segmentation. Whether it's at a subnet level, whether it's at a network level, at a resource group level, which is an Azure construct, or you're doing it at an application tier level, right? And that gives you, obviously, better security and even compliance, especially for PCI, PII workloads. You're segmenting where your data lives and protecting it strongly. The second thing, I already mentioned it, you want to inspect everything. The traditional architecture, I think I'm sure you're familiar with, is that hard exterior, soft interior. Obviously, you want to now go towards a more, let's say, zero trust-like idea, so that you're inspecting between tiers, and that way you can restrict that lateral movement of threats, especially from low trust to high trust areas. And then you again want to now whitelist applications. So if you're going from application tier 1 to application tier 2, let's say web server to database, you might say, I only want SQL calls to happen. And application tier 1, tier 2 can only talk to DNS zone for the DNS-related traffic or for Active Directory traffic. So you're segmenting at a clean level and just allowing things that you want and not everything else. So on the flip side, on the same logic, management tier, you may say only RDP and SSH are allowed by only the AD group for admins, right? So basic stuff that you've already known, but I'm repeating it in a cloud context. And restricting that destinations, again, expanding on that one is that east-west flow, north-south flow. You want to think about those. And what this gives you is the ability to make sure that malicious traffic is not going to command control servers, for example. Because in that outbound example I gave earlier, if you allow outbound traffic to, let's say, 443 SSL, because that's where all the Linux updates come through, you want to say, I only want my Linux VMs to go to ubuntu.com or canonical.com. And it should be only apt-get or yum update, whatever your Linux update server is. So that way you've said, outbound traffic only goes to these destinations and only this kind of application. The alternative way of doing via pure NSGs is you got to whitelist all the IPs in the Azure NSG, which is a lot of work. It's doable. But an advanced platform would be able to say, this FQDN or this DNS name, that's all I allow traffic to go out to. And that's a really easy way to enforce these controls, right? So one thing I didn't mention is, obviously, you want to leverage NSGs and ASCLs for basic security, right? That's like security 101. In the last part, I mentioned the cloud elasticity idea. You want to build scale-out architectures. For the single point that, you don't want a single point of failure. In on-prem world, you may build a massive firewall and create an active-passive or active-active pair. And one guy fails, the other guy takes over. You have a massive investment of on-prem infrastructure. In the cloud, the benefit is the cloud load balancer is your friend. It's a horizontally scalable, elastic load balancer. And then you put firewalling units behind it for scale-out. It's the same thing you're going to have to do for your applications also. I mean, initially, you may do a lift and shift of your applications, but eventually, you want to build a more cloud-native application stack. And obviously, that's a difficult journey. But you want to push towards that. OK, so now I'm going to switch over to a demo and show you how we do this. So deploying virtual firewalls from the marketplace is pretty easy. You go there, you find us, you deploy it. Really easy to do it, and it takes a while to learn what are the basic constructs. But you can deploy us for some of these scenarios. You can secure inbound, outbound, and east-west traffic in Azure really easily. And I'll show you all the details on that front. But doing this at scale was previously very hard. Recently, Azure has introduced a lot of features that make this extremely easy. So for the networking and security folks, this is going to be really amazing. No other cloud platform today offers these kind of capabilities, right? It's like my free endorsement for them because I love what they've built in this front. OK, so let me show you some specific reference architectures and use cases, right? So the first one is, so I got a laser pointer here. OK, I don't think it's going to reach. OK, so this is a typical sandwich architecture for web applications that are internet-facing. On the front end, you've got the application gateway. This is Microsoft's web load balancer. It's got a bunch of features like SSL offload, HTTP-based redirection of traffic, typical things that you expect a web load balancer or an ADC to offer. And behind that, you got 2 or more firewalls, right? Again, like I said earlier, scale out. And as you need more firewalls or less, you add or remove. So traffic comes in, we inspect all the policy that you want us to inspect, and then we send it to the internal load balancer that front-ends your application tier. The beauty of this architecture, as I highlighted, is you can add or remove more firewalls as you need. You can add or remove your web tier as you need for scale, right? That's the whole point of the cloud, elasticity. So the additional advantage now you have is that Azure recently enabled a WAF functionality in their application gateway itself. So you're going to be asking me, why do I need a next-gen firewall and a WAF, right? So traditionally, it's been a little bit hard to cleanly understand the differences. Here's the main difference. The WAF is focused on pure web security alone. It's looking at flaws in application logic in web applications. So this is your typical SQL injection, cross-site scripting, things like that. So it's going to look at layer 7 web only. Our focus is to look at all kinds of traffic, layer 3 to layer 7, and we're going to look at for advanced things. For example, if your website has a form where people are uploading files, documents, and so on, the WAF is not going to look at those things. But as a full next-gen platform, we're going to look at it and say, oh, wait, some malware was in this document file, or this executable has some bad things. There's a lot of other capabilities that we bring in, so I don't want to turn this into a marketing conversation, but if you are familiar with the next-gen firewall, there's a good set of complementary features across the board. Right? So this is inbound web applications. Here's where a lot of the interesting conversation happens, which is the outbound example that I mentioned. So on the right side of the diagram, you see I've just mocked up 2 application tiers, web and database. Obviously, there could be multiple. So this is where the Azure architecture shines really well. So you've got all these tiers of applications, and you say, I want to investigate and control east-west security. You can use the Azure UDR feature, user-defined routing. Right? It doesn't mean end user, it actually means admin set routing policies. If you're familiar with PBF, policy-based forwarding, it's kind of the same idea. The idea is you say, my traffic is going from the web tier to database tier. I want the traffic to go to this other place. It could be a single firewall instance, or it could be the Azure load balancer. So those red dots are showing that the traffic is being forced from the web tier to the load balancer. And behind the load balancer, I've got 2 or more firewalls. And I'm saying specifically 2 or more, because that's going to give you high availability. Okay? And now what you can do is web goes to database, firewall inspects it, applies all the policy you configured. Same way, when web goes out to the internet, let's say to do Linux updates, firewall sees that traffic, inspects it, applies policy. This used to be fairly hard a couple of years ago. Now it's really easy in Azure. So what that means is that your application teams can build their apps the way they like. You as the network and security teams can go and set up those VNet UDR rules to say, traffic flowing from here to here, it's important, it needs to be compliant, send it to the firewall for inspection. So that's sort of the basic concept. Now, one of the limitations used to be that any load balancer, like the Azure load balancer, would require you to configure the ports that you want it to load balance. Right? So if you say, I've got SQL, okay, I got to configure, 1453, I forget the exact port number. But if it's got SSL, you got to configure 443. I've got NTP going out, I need 123, and so on. So this was fairly painful. If you've got lots of applications and they use lots of ports, you got to configure every single port in the load balancer. That's very painful. You just can't do this at scale. So the second problem in sort of trying to do this in a bigger way is, what if I want to build a centralized common security stack? So this is another beautiful architecture in the idea that each application has its own set of firewalls that protect that application. And the firewalls are scaling in response to demand for that application. So the web application is very popular. It's an internet-facing one. I need 10 virtual firewalls, each running half gig to a gig, let's say. And then the bottom one is a custom private application. It needs some security. You may put 1 or 2 virtual firewalls there. And you say, you know what? I want to centralize some of the security in a common place, especially when these apps try to reach my on-prem data center, or they're going to the internet. Those are specialized needs. Those are not everyday needs. You can build this architecture today in Azure by peering these VNets and putting us behind the load balancer like I showed. That's a scale-out architecture. So this, again, has that same problem that the load balancer has to be configured for every single port. That's a lot of work. You don't know what ports your apps are going to use. It's always a nightmare for any admin to go find out from the application developer. Even the app guys don't know what ports they're using. So to solve this, we've been working with Azure networking team and saying, guys, we need some solution, help us out. So they introduced 2 features. One is called floating IP mode, and I'll explain the technical details in a second. That's been there since the beginning of this year, and I'll show you the details. But the second feature they just announced at this conference is called HA ports. The idea is that the load balancer now does any port, any protocol load balancing. That means you can, without any fear, say all traffic just show up at the load balancer. Load balancer is going to spray it across all the firewalls. Firewall is going to apply all the policy. Whether it's SQL, this, that, whatever application, the firewall now controls an application layer policy with malware inspection, command control blocking, all those advanced logic. So this is sort of the combo beauty of this. The floating IP feature is an idea that normally when a load balancer sends traffic to its next hop in the load balance pool, it always destination nats that traffic to the next hop. Well, if you imagine an outbound traffic, right? Let's say a Linux VM is trying to go to ubuntu.com. If the load balancer destination natted that packet, we will not see the destination that was originally intended, which is ubuntu.com. So the load balancer has this feature that they call floating IP. What it means is that underlying is they don't destination nat that packet. We will still see that packet, and it's not been destination natted. It still has the ubuntu.com address. We look at policy, says, oh yeah, it's allowed by these VMs, allow it. Oh, it's going to some other place, block it. So that's sort of the underlying capability there. Okay. So that's the capability that Microsoft just introduced. And the idea is that traditionally you would have configured the port protocol for that HA ports feature. Now, I know it's hard to see this, but this is the new UI, where you just enable in the load balancing rules, you enable the checkbox that says HA ports. And that means all port protocol is supported, essentially. I think their idea when they said HA is that high availability of ports themselves, so that you're not individually configuring all ports, right? Any questions? I know that one's really sort of a little deep and intense, and if you've not played it, it seems unfamiliar. But I'd urge you to try it out. This feature is in preview now. So if you go to their Azure networking blog, there's a link for this, and you can sign up for this feature if you want to try it out. Okay, so I'm going to switch over to a demo. I have recorded the demo so that the demo gods don't play unfavorable things with me. So what I'm going to show you in the demo is this. All right, let me try to zoom out the video a little more. It's the same diagram that I was showing earlier. What I'm going to show you is that on the right side, this web tier is my backend network. And what I'm going to try to do is this traffic is going to show up at the load balancer. Load balancer is going to send it to the firewalls. The firewall is going to inspect that traffic and then enforce policy. All right, let me go ahead and start the video from there. And I switch over. OK, so this is, oops, sorry. So that was actually the firewall console, but I'll come back to it in a second. So this is my Azure console. I've got all this set up. I'm going to switch over to the load balancer in a second. OK, so here's the load balancer. And if I go to that outbound load balancer, the one in the middle, I'm switching over to the load balancer rules. And what you can see is that it says load balancing rule all means all protocols, and the 0 means all ports. And I know this looks very cryptic, but if you're a load balancing person or a network admin, this should look very familiar. But that's the idea. This is going to load balance all ports protocols, so TCP, UDP, and even ICMP inside the VNet, and all ports, right? OK, so let's carry on. That's what's been configured on the load balancer. OK, so if I go back to the firewall, I've got two firewalls, as you can see. And this is my monitoring tab of traffic. But here's the security policies that I've configured. And the policies I've configured for demo purposes is this. I'm blocking all FTP, because it's kind of a bad idea to allow FTP outbound. I'm allowing Linux updates. And I'm saying for Linux, only allow apt-get. Right? That's a typical Linux update for an Ubuntu server. And then below it, I have a policy called allow all. Obviously, in real world, you wouldn't ever do that. But for demo purposes, I'm allowing all so that I can see what traffic is trying to go out. Right? And then below that is, I'm denying all traffic, but I'm logging it so I can to see what I was blocking. Right? So it's a very simple policy set, more for demo. So that's what I've set up in the firewalls. So now I'm going to show you, if I go to a Linux VM on the back end, what happens. Okay, so I guess I'm just talking through the policies, and let's get to the next step. All right, that was the talk track. Okay, so now I go to the monitor tab where I should see all the traffic. So I go to this Linux VM on the back end. okay? And I try to retrieve a page from the internet, right? And what I should expect is that I should see some traffic for it, and I'm going to do a Linux update. I know it's a little bit hard. Hopefully it's visible. I'm just trying to do a Linux update on my Linux VM in the back end, right? So this is a typical operation IT admins perform for maintenance reasons. So if I go back to the firewall logs and I refresh, I should see those web traffic and the Linux update commands. You can already see that the load balancer is already load balanced NTP and all these traffic streams. And you can see the SSH showed up. And then there's all these other traffic streams that are showing up. And to basically make sure that you see this, right, the idea is that all these ports is what the traffic is causing or using, and the load balancer is taking care of those things. Traditionally, like I would have said, you'd have to configure individual ports, and that's a lot of work for IT admins. This makes it possible that as you turn on new applications, you just come to the firewall and say, these apps are allowed, these are not allowed. You don't have to muck with NSGs, and port protocol, load balancing, all that, it's taken care of. And that's the beauty, that security now can keep control of what's going in, what's going out. And that's how you essentially are going to be able to prevent exfiltration, right? The whole premise of the talk is, how do you prevent exfiltration? The way to prevent exfiltration is, you only allow known things, known applications to known destinations, right? In that table I showed you, whitelist applications allow traffic to only known destinations. That's how we are going to do it, right? Okay, so let me carry on. There's also a Windows machine that I have on the back end. So I'll show you a basic example of if there was a Windows machine on the back end and not just a Linux machine, what would happen. Okay, so this is the Linux machine, a Windows machine, and I sort of tried to go to our company website. It's going to go to the load balancer, and then it's going to go to the firewalls, one of the firewalls, right? I don't know which one it's going to end up on, because the load balancer is going to decide. Okay, so I go back to the firewall, I do a refresh to see what traffic showed up, and you'll see all these websites. Obviously, a lot of our content is cached on different servers, so the content is coming through different things. And you can see most of the traffic was SSL. And if I go to the other firewall, I think if you notice that I switched over the tab, because some traffic may end on one firewall, the other traffic may end up on another firewall. And you can see all the traffic showed up here. So now I'm going to try to download an FTP site, right? If you remember, I set up a policy to block FTP. If I reload this, FTP is not going to show up. If I go back to the let me go back to the firewall logs, and I go to a refresh. And you can see FTP actually got blocked because of policy. And obviously, it was trying to use port 21, right, as FTP does. So this is sort of that combo powerful capability that this architecture gives you, right? Okay, let me switch over to the slides and sort of kind of reiterate the concept. So these are the three capabilities that Microsoft brought together that I had mentioned earlier, right? User-defined routing to load balancer. Basically, send all traffic to the load balancer. Let the load balancer spread the load across 2 or more firewalls. And then the floating IP mode makes sure that it doesn't destination NAT the traffic in the load balancer, which means the firewall can actually apply policy. And then finally, the new feature, which is that the load balancer will load balance all traffic. And I know this is all the technical details, but in the end, it gives you this glorious hub and spoke model. The spokes are all the application stacks. You can put security close to the spokes, close to the applications, and you centralize the common needs in a centralized stack. This makes it really powerful. Now, you're going to obviously ask, wait, there's a lot of firewalls over here, all these firewalls. I usually buy 5 firewalls to protect my entire enterprise. And those are big honking firewalls, going from 5 gig to 200 gig, depending on what your needs are. The idea in the cloud is really all about distributed and scale out. Every one of these firewalls in each of the contexts is a cookie cutter firewall, each managed from a single centralized management server. Each of them has the same exact policy that is suited for that application. And that gives you that flexibility that you're not managing individual firewalls. All you're doing is adding or removing capacity. When that firewall comes up, it's going to talk to the management server, get its policy, and operate it just like a cookie cutter firewall. That's sort of the cloud scale out idea. Okay. And this is sort of enabled by that floating IP and HA ports feature of Azure. Okay. So the last example I'll give you is this idea of that orchestration automation. We are showing a demo in our booth if you had a chance to come by. I think the booths are open till 4 o'clock. So here's the idea. What if you wanted to daisy chain or trigger events when the firewall found some bad or malicious things, right? Let's say you're being brute forced or some particular kind of threat or malware was found in the firewall. What if you wanted to do some automation? Here's the idea. Our firewall supports something called as action-oriented log forwarding. You guys can repeat that? It's really hard to say it. Action-oriented log forwarding. All firewalls have log forwarding. In addition to just normal log forwarding, you can set filtering rules to say, if I find this malware, or if this condition exists, meaning I was brute forced 20 times, or this happened, I want you to take this additional action. And that additional action can be any HTTP call, essentially a post you can make. So here's an example of what one of my engineers did. He built this basic policy and said, here's the Azure credentials, fire off an Azure function when you see this log event. What that does is, it fires off an Azure function, and what that function does is, if a certain malware is seen in a certain VM, it quarantines that VM. Just makes an NSG call to Azure API and says, lock this VM down completely. If you want, you can shut it down to whatever your choice is. And then you can go do remediation in that quarantine area. So this is a live demo that's in our booth, and you can obviously build this yourself. So this is calling to that API and automation capabilities in the platform. Okay, if you want to build some of these things, you go to our GitHub repo, github.com/Palo Alto Networks. There are lots of templates for Azure, AWS. And there's this template that one of our partners also built. So you can try out some of these things yourself. And it's got all these capabilities for inbound, outbound, web apps, east-west security, all these capabilities. Okay, that's about it. I'm going to hand it over to Megha to talk about SaaS security.
Hello. Yep. I'm like red and green colorblind, and this is like red and green. Doesn't help. So we're going to switch topics a little bit and talk about Office 365, and in general about SaaS applications, the whole shadow IT, proliferation, what's happening in the SaaS world. Now, if you look at the way users use SaaS applications, we put them in like 3 buckets out there. You have the sanctioned apps, which are deployed by your IT organizations, and these are the apps which you're using. I mean, Office 365 being one of the most used sanctioned SaaS application out there. And then there is the bottom bucket of the unsanctioned SaaS applications. This is my favorite bucket. Actually, it's not my favorite bucket. So there are apps like Prezi. My kids' school, actually, they use that app. It's an awesome app which you can make nice presentations and all of that kind of stuff out there. But then they have like the terms of services say that if you're using a free version of Prezi, any content in Prezi becomes public use. So that's the kind of app where enterprise like us are like completely scared, because you don't want your content to change hands when you just use a certain app. And then of course there are apps like Zippy Shares and Mega Uploads and all those kinds of file sharing apps. The primary purpose of those apps have been in the past illegal pirated content and things like that, games and all of that. Very good websites to get latest movies and things like that. And then there is that middle category out there, the tolerated apps, which are used by your partners, which are used by your vendors and all of that. And we actually have a lot of auditing companies who we work with. Our finance teams, they work with them very closely. So we need to allow those apps, but at the same time, we need to monitor what's going on into those apps. So this is the landscape, I would say, of the SaaS applications you have, right? You want to block the unsanctioned apps, which are really, really bad apps, risky apps, and all of that. You want to carefully allow the apps which are being used by your partners, by certain groups within your organization. And then, of course, you want to allow sanctioned apps, but then you want to keep an eye on what's going on over there. So what does the industry do to solve this, right? So in the last few years, the whole industry emerged called cloud access security brokers, a term which Gartner has been using. And one of the primary things they do is they put a cloud proxy. And which is something, we all know, they have their own limitations. There are other CASBs. What they do is they are asking you to take the logs from your firewall, from your proxies, I mean, the people who do not have proxies, they're asking you to upload those logs periodically, or put up a log forwarder which takes these logs and then uploads them to their cloud service. Then they will ask you to put a traffic forwarder which will then go in and take that traffic and then inspect that traffic and figure out what that traffic is. And then you want to know who that user is, right? I mean, who that user is, map that log to that particular user, see what kind of usage they're doing. So they will ask you to put an AD connector to. And then you have remote users and you have on-prem users. So if you have an on-premises user, then you put a packed file so that all the traffic from the packed file goes to that proxy, and then you can inspect that file. If you have a remote user, then you put an agent, another agent. It's a VPN. I mean, that's what is this agent which is taking traffic from a remote user and sending to a cloud service? It's a VPN agent. So let's call it an agent. This fancy agent which sits there, takes that traffic to your cloud service so that the cloud service can then inspect this traffic and all of that. So this morning, I was talking to a person, and they had 35 egress points in their network. It's a pretty big company. They have 35 egress points. So what they're asking you to do is repeat the same thing over and over in every single location out there we have in the world. This is just an unmanageable way of getting visibility into your network. It's inefficient. And if you look at some of these solutions, I was actually seeing a solution last week. It said star.dropbox.com is the URL which you're supposed to block or allow in a granular fashion. The problem is Dropbox content does not always get rendered from star.dropbox.com. Just like you saw paloaltonetworks.com was getting delivered from Amazon AWS.com and various content distribution networks out there. So just putting URL-based rules around blocking or inspecting traffic applications just doesn't work. So that's what you have. I mean, and then you know what? We actually have a customer who did all of those things. And then they had a user who was using a VPN to circumvent all of that stuff and then just go to the cloud proxy, I mean, skip the cloud proxy and then go to their whatever app they wanted to use. Because proxy is looking at HTTP, HTTPS traffic. It cannot do anything beyond that. I mean, you have the onion router, I mean, which can skip anything in the world and then just go away from all of that. So now we have wasted our time putting a log forwarder, putting a traffic forwarder, a pack file, an agent, and all of that. At the end of the day, it just doesn't give you the security which you are expecting it to do, right? That's why we had this solution. I mean, we had this solution from 10 years ago. I mean, this is the next generation firewall, the entire market of next generation firewall, which every other firewall vendor then copied, has been trying to copy for the past 10 plus years. They have been doing it, and this is something which you have, this ability is there. And this ability has been there from the day one. I mean, we had 100 applications when we started out with, and now we have close to 2,700 applications which we can give you very, very granular visibility into. And these are not just URLs. This is a protocol decoder which is actually looking at which application is using which protocol, how that application is, building that URL, how that application is saving cookies, headers, everything. We monitor every single thing. We have a user ID which identifies a user and figures out which user is going to which application. The nature of content which is going through to these applications, whether it is a file upload, file download, which type of a file it is, a PDF file, a Word document, look at the properties of those files, look into the content of that files, all that stuff is there from the day one of the next generation firewall. So all we were missing was an easy button. So if you have been using our firewall later, I mean, any version of 7.1 and above, you have all this visibility into your SaaS applications. This is literally one button click. You can generate a SaaS visibility report. You can identify which applications are being used, which SaaS applications are being used, mark them sanctioned, unsanctioned. Everything by default is unsanctioned. You can mark them sanctioned, and then it becomes green and green. And we had so many success stories already. Some of our customers who have been using this report to reduce their SaaS footprint. One of the best examples I remember was there was a company which was using BoxNet Enterprise, which is the Box Enterprise version, and they had 3 terabytes of data going to their Box Enterprise. No surprises there. Their number 2 application in their company was Google Drive, and they had 2.5 terabytes of data going in a month in the same time period going to Google Drive. For the CISO, that was a big shock because they were paying millions of dollars to Box, but they had users using Google Drive. So what they did was that they just took a captive portal functionality which we have, And anytime a user goes to Google Drive, it just throws a warning saying that BoxNet is our enterprise files sharing and collaboration app. Why don't you use that? And user has to say, okay, and then it takes them to Google Drive if they still want to do it. But then at the same time, it educates them saying that and discourages them from using Google Drive. So they ran that report, same report, 6 months later, and then their Google Drive usage went down from 2.8 terabytes to 150 MB. Only a few users were using it, and that too certain vendors and certain vacation pictures and stuff like that were going to Google Drive. So just by taking a very simple captive portal approach, these guys were able to reduce their risk footprint. We also have a SaaS dashboard. What you can do is you can actually drill down live traffic through our ACC and then look into which user, who's that user, why they want to go to these applications. And you can identify them and you can allow them. Maybe it's just one department within your organization which is going to that particular application. We have our finance team which uses a lot of weird applications which no one else in the company uses. So we want them to allow, we want them to be productive, and we want them to allow all those applications. So we just have some rules which allows if user department or user group is finance, then you can go to this app. If you're not finance, then you cannot go to those apps. And if you have any reason you believe that you want to go to this app, tell us, and we will allow you to go to those apps too. So by just taking small measures, we were able to reduce our risk footprint and secure our SaaS app propagation itself. The other thing is that now you can take a few steps and reduce your shadow IT very, very easily. But then what about the sanctioned apps? There is a lot of things happening on our sanctioned apps too. We have all sorts of next generation exploit protection and network level malware protection and all of that. But our vendors, we interact with around 120,000 vendors around the world. We don't know what they are running, whether their AVs are updated, whether, first of all, they even have like basic Windows Defender even turned on, right? So, but at the same time, they can upload files into our SharePoint, into our Salesforce, and who knows what kind of files they're uploading. And these, all we need is one single collaborator to upload a malicious document into our SharePoint, and then from my home PC, which is not as secure as my work PC, I can download that file and then do something really damaging. And then same thing on the data exfiltration side too. A malicious user in the past has to get into your network and then expose a file. Now with these SaaS applications, very easy. You can just expose a folder publicly and then download all the data from that folder rather than downloading and getting into your network and then trying to stop that stuff. There is this other problem. It's actually the biggest problem when it comes to these SaaS applications. When we first deployed SharePoint in our company-wide, we didn't give our users any training on how to use SharePoint. We didn't give them training on these are the 5 modes of sharing on SharePoint. We just said, hey, SharePoint is available now, you can go use it. The problem with that is users make mistakes all the time, even though there are so many checks and balances put within SharePoint. I mean, I share a file with Jigar because he's PM teams. He's not supposed to share that file with the rest of the world. But I, as an owner, I don't know who Jigar is sharing files with, right? So I lose complete control the moment I share the file with him, make him an editor on a file, and then he can just go in and share the files whoever he feels like with. The other thing which happens, and this happens a lot, is this is the Outlook fat fingering problem. Now can happen with any SaaS applications too. You are trying to type share a file with Mark, our CFO. Instead, you type in marketing, and now everyone in marketing department has access to your financial documents, and they can all share, and they can link, and they can edit, they can do whatever they want with those files out there. Now, there is this other problem also is, if you look at how these apps work, right, there is a inheritance within these applications built in. Our marketing team on Box, we have a lot of content which is actually publicly accessible, and it is white papers and tech notes and things like that. Now, someone from our team, the product management team, went in and put in a product requirements document, subfolder, like 10 levels deep into that folder. So what happened is, because of the nature of the way the inheritance rules works, that document became publicly accessible with our partners, with our vendors, as well as many other people in the world out there. So this is a problem which the inline protection, a firewall, any device which is sitting between a user and the application can never, it doesn't have that visibility, because this is not something happening when a user is uploading a file. As a user, I can upload content to Box, that is allowed, but I cannot upload it to a public folder within Box. That's what we're trying to stop here. So that's why we went with an approach of an API-based protection. These are like app connectors, which can tie in directly back-end from the cloud service which we provide to the cloud service which the SaaS application vendors provides. And the best thing about it is that it preserves the user experience. The user don't even know that there is something in between the user and the application which they have to go through, and they have to protect that. There is a lot more context in these API-based solutions because we are looking at data at rest sitting in those SaaS applications out there. We can monitor the user activity, whether they are coming in from China, whether they are coming in from Santa Clara, or whether they are coming in from Orlando. Which device, it doesn't matter. If it could be a BYD device, it could be a managed device. You can always monitor what kind of activity that user is doing. In addition to that, you can also monitor security controls. These are things like someone has a forwarding rule set up in Exchange, or an admin is impersonating a user and looking at users' emails. So you can actually monitor all that kind of stuff too. In addition to that, one of the biggest things which we are seeing is third-party integrations. So you can monitor all of that using these API-based solutions. So we have an API-based solution. It's called Aperture. It is a standalone SaaS-based service. It provides you complete visibility into all the content you have in your SaaS applications. Then it takes the context, how that document is being shared, how that content is being shared. Together, it creates a composite risk and then presents those risks to you and say that this is how you can solve those problems. You can quarantine them. You can notify the user, say that don't repeat these mistakes. You can remove the sharing of those applications. And since it's looking at all the content, what it will do is it will actually inspect that content if there is any malicious content in those documents too. It doesn't have to be executables. It doesn't have to be DLLs. It actually looks at documents, PDFs, all sorts of various files too. If there is a completely new type of a document which we haven't seen, which there is a macro in a document, in an Excel spreadsheet, we submit that file to our sandbox service, which is actually the world's biggest network-based sandbox as of today now. And it figures out whether that file has anything malicious in it, notifies Aperture saying that there is a zero-day malware in this particular file, and then you can quarantine that malware. And the best part about it is it actually retroactively looks at all the data which is there in your SaaS applications. To give you an example, right, we actually had a contracting company we were working with to develop some app for one of our mobile initiatives. Now, this contractor's contract was terminated 2 years ago. What we found out was that contractor access was not removed 2 years back. So when we ran Aperture, we actually noticed that this contractor not only has access to all that source code, but this contractor was intermittently even accessing those files because they had access to all of that files. They were downloading them and they were checking them. They were seeing what changes are being made to those files. So that's the best thing about Aperture is it actually looks at all the problems which are there in your SaaS applications from the day you purchased your SaaS applications, not just Aperture itself. So how we do it is, first thing is we classify every single thing, every single content which is there in your SaaS applications. So we have the standard identifiers, pattern matching based identifiers, that's what I like to call them. There's a longer list. I picked some of the more popular ones we have in our list. So PCI, PII kind of stuff. In addition to that, one of the biggest things which we are investing in is looking at unstructured content, sensitive content. What I mean by that is rather than looking at patterns and doing patterns matching alone, which is what credit card numbers and all these numbers do. If you know the DLP word, they do some pattern matching, then they do some checksums, and then they look for some proximity words around that. And based on those, they will say, oh yeah, it's a credit card number, it is a social security number, and all that. What we are also investing in is a big time is into machine learning based document classification. What that means is just by looking at certain words and the frequency of those words in a certain type of a document, we can figure out what is that document. There are other companies which were doing that, but what they required you to do is that they need a huge training set, what they call a positive training set and a negative training set. For instance, I mean, we have a document classification type called financial accounting. So they would ask you to give you like 1,000 financial accounting documents, which really are financial accounting documents, and 1,000 documents which kind of look like financial accounting documents, but are not financial accounting documents. I mean, no one in the world has that time and patience to create those models and then, you train those models and all of that. So what we did was we crowdsourced that entire thing. We built those models and we jumpstart your entire training process so that as soon as you connect Aperture to it, it will automatically pick these documents without you doing anything, any training or anything to that. Now, in addition to that, we also look at activity anomalies. So if there are certain patterns which are malicious, one of the things which we notice is people, before they resign, they start downloading a lot more than their regular day-to-day usage. So we can monitor things like that if there are anomalies like that. In our Salesforce, we monitor if anyone is downloading more than, so heuristic-based analysis we can do, where if anyone's doing more than 1,000 reports export per month, why are they doing that? I mean, what is the reason for ever to do it? We have some sales ops people which they need to do it, so we exempt those people from doing those kinds of behaviors, but any sales guys doing it, we monitor those kinds of stuff. And then a little more on this, right? So there are third-party apps. I mean, this is something which I spoke about briefly. So what these third-party apps do, it is I mean, I have like Box and Google over there, but every app, even Office 365, has a huge ecosystem of apps where you can actually build an app which takes the OAuth credentials of a user, and this is the end user who can actually install it. There is a Starbucks app on the Office store. You can actually, as an end user, I can go in and install the Starbucks app for my profile on my O365. This actually happened for Google a few months back. There was a researcher, he calls himself a researcher, Eugene Pavlov was the name of that researcher. What this person did was, he created an app, named it Google Docs. It was not Google Docs. It was not even published in the Google store. And he sent it out to a bunch of people. What this app does is it actually asks the user, do you want to install Google Apps? But if you pay a little attention, it's actually not Google Apps. No one pays attention. They said, yeah, let's install Google Apps to look at this particular document which my friend has sent out. And it asks for contacts. It asks for accessing your contacts. It asks for accessing your Google Drive, the files in Google Drive. And then it sends all those people an email saying that, do you want to install Google Drive, Google Docs, and all of that. So it spread from 0 to 10 million users. It did that whole thing in like a couple of days, I think. And it started extracting all that data and then sending it to some person's Google Drive account or in Russia, obviously, somewhere. So turned out it was actually a genuine mistake some user did, but he didn't realize the damage it could really do. Now, that was an innocent mistake. Someone can do this very easily. So we have a third-party app firewall on Aperture for Google Docs. So if the users who had that, or the customers who had that particular thing turned on, we have a very simple thing. What it says is, if the app is not published on Google Marketplace, don't install it, or just block that app or revoke that app. So if any user is trying to do that, it will automatically revoke their OAuth credentials and not let them share any data before doing much damage to that particular enterprise or for that user itself. Let's talk in a little bit about what Aperture can do for O365. When I talk about O365, there are I would put them in 3-4 buckets. SharePoint, OneDrive are almost the same app. The big difference being one is a more personal thing, the other one is more for your teams, Exchange Online, and for Yammer. Now, you might ask, what does Aperture add value to me if Aperture is actually looking at the data at rest? And then if I have a proof point or an MTA kind of a solution, or even Exchange security, what is this additional thing which we can provide, right? One of the biggest advantage is protecting against zero-day malware. Now, if you look at any zero-day malware, there is always an evasive period where the malware can actually make it into your system before getting detected by all the sandbox or any sandbox in the world. The reason why that happens is, no matter how great your sandbox is, it takes you at least 5 minutes for that to be analyzed. And we actually noticed that in one of our customers, one of our largest customers, their CEO got a file on December 6, 2016, which was a malicious document. On December 7, 2016, every single sandbox, Symantec, McAfee, Kaspersky, Palo Alto Networks, everyone said that is a malicious document. This is a Trojan, we classify this as a Trojan and all of that. But the problem was that the CEO actually got this malware a day before everyone else went in and flipped that signature out there and spread that signature. And when we connected Aperture to that particular customer's exchange, Aperture said, well, there is a known malware there sitting in this CEO's inbox. Do you want to remediate that? Do you want to quarantine it? And of course, they went in and quarantined. And then another big thing which Aperture does is monitors those rules which we have. I mean, I mentioned this briefly. So this is, again, another really, really silly thing which happened in one of our government customer. This person in their company, every single email which had purchase order in the subject, she was forwarding it to her Yahoo account, Yahoo Mail account. And when her boss asked, why are you doing that? She's like, well, I don't know. I mean, it's just because when I go home, I can access all those emails and I have to work on those things, right? But what is happening is that if this person ever leaves the company, she still has all those purchase orders and everything, which she's never supposed to even access that in the first place from any BYD device. So Aperture can actually look at those order forwarding rules, and then if they're especially going to untrusted domains like Yahoo's and the Hotmails and the Gmails and all that, it can alert them, it can alert the users, it can take some remediation actions. If there are public folders and sensitive content getting into public folders, which are not supposed to be company-wide available, it will detect those things and it will say that these are data going to public folders. We have a 1-year retention policy on all our emails because of legal hold issues and legal problems and all that. Users can override them for certain real reasons if they have, certain users they have. So our IT, our InfoSec team wants to monitor who are the users who are overriding the retention policies and what is the justification for those users to override those retention policies. In addition to that, we can also monitor if there are admins, and we have like 60 plus admins on our Office 365. If admins are impersonating certain users, I mean, our lawyers are the biggest requirement. I mean, it was a requirement driven by those guys. If any Office 365 admin is impersonating a lawyer and looking at their emails, our InfoSec wants to be alerted when those kinds of stuff happens. So those are the kinds of stuff Aperture can do because it is actually looking at data at rest, and it is using those control APIs which Office 365 provides. For SharePoint, similarly, we can actually do a lot of stuff too. We can look at what sites are there, default sites, non-default sites, what kind of content is going there, how that content is being shared, whether it is a public link, whether it is shared with some untrusted collaborators, stop those kinds of stuff. Of course, if there is malware, we can quarantine them. You can stop the propagation from SharePoint itself. Same thing for OneDrive too. SharePoint and OneDrive, almost the same app. It's just how it is being used. That's the big difference between the two. And then finally for Yammer, I mean, we actually we can monitor Yammer networks. What kind of content is going within the Yammer networks? Who is it getting shared with? If there is again malware, we can quarantine it. We can stop that malware. We can detect it. And then finally, we added one more thing about IaaS. And today we have support for AWS. We're planning to add support for Azure blobs and containers very, very soon. We can actually detect what kind of content is there in your AWS buckets. And we don't just look at the buckets exposure itself, even within the buckets policy. At an object level, we'll say that this particular object is publicly shared. You've probably heard about these horror stories, I mean, where a defense contractor was taking some files and putting them in a S3 bucket, which was publicly open. All those kinds of problems and embarrassments can be avoided if a thing like this is running and detecting the problems which are happening in your AWS infrastructure, in your IaaS infrastructure, and then remediate all those problems like that. So to summarize, I mean, we have what we call like very in-depth support for sanctioned apps. There are about 18 of them, and we add them around 2 to 3 apps every quarter. Facebook for Work is coming up. Azure blobs and Azure storage containers is coming up. So that's the rate we add on the sanction side on the Aperture. We have apps which are sort of on-premises like Jive and share files and all of that, which works in these hybrid modes and all of that. So we can support those at ServiceNow. So we can look at content, activity, everything on these apps. And then on the unsanctioned apps, and when I say apps, I don't mean URLs. So of course, we have like few 100,000 URLs where we go in and put them in buckets of like, you know, gaming and adult and things like that. So a bunch of hundreds of thousands of URLs. In addition to that, there are 2,300 plus apps where we can granularly say that these are the apps, these are the application controls, the application risk, and we keep adding more and more new applications as we see and customers request.
Last slide.
And last slide, I'll let you actually finish this.
Okay, so hopefully we didn't intend this to be as a company pitch, but what we're trying to highlight is that next-gen platform needs a lot of capabilities. I talked about the IaaS capabilities in Azure. Obviously, the same things extend to on-prem data center, so that's the on-prem network capabilities we have, which is the left side. The middle section is the cloud capabilities that I talked about and Megha talked about for SaaS. And then there's also next-gen capabilities we've built for the endpoint, where we just focus on not malware signatures, but exploit capabilities like heap spray, memory exploitation techniques. So the focus is on exploits. So that's the capability we've built for protecting endpoints or your desktop or server machines. Okay, with that said, we have about 12 to 14 minutes if you guys have questions. Thank you very much. And of course, I forgot to say the last thing. Please evaluate the session. I think we will look at it. Microsoft wants to know the session details. And if there's any questions or microphones, or just feel free to speak them out. Somebody? Nobody? Repeat the question.
You just purchase licensing for Aperture.
So we have.
Repeat the question, please. Yep.
Okay. So the question is Aperture a different SKU for every single app? Or so the answer is we have two license modes. There is a one app license mode and there is an all apps license mode. 95% of our customers have an all app license mode, so which gives you not just the 18 apps which we have today, but any future apps which we add also.
So my favorite one is GitHub.
GitHub,
All my developers use GitHub. Some of them don't know that when they use the public GitHub with the free account, everything they write in the repo is public to the internet.
Yeah.
And if their GitHub client on their desktop syncs their stuff, they often have SSH keys that get synced up straight to GitHub. And even if you have a private GitHub repo, you have to be careful where you're syncing. It's like GitHub is like that easy gotcha in that way. Okay, good question. Others?
For PCs in the wild, at a person's home, at whatever, how does the application protect against the SaaS environment? It's not going over a corporate network. It's just going directly to the internet. Is there a plugin of some kind into the SaaS app, or?
So is this a use case where I'm from my home PC directly going to my corporate Salesforce or corporate office?
Maybe you have some conditional access in there,
right,
and you've been allowed to go through conditional access. You're on a managed device or whatever.
Right.
But how does it still uphold the idea of sanctioned, unsanctioned apps?
Right. So there are a couple of ways to do it. I mean, conditional access being one of them. I mean, we actually have something similar to, we have a reverse proxy, our clientless VPN and all of that. So today the way it works is you can actually put in an IP restriction on your Salesforce or something saying that if the traffic is coming only from these known set of IP addresses, then allow it. We have a SAML proxy which is coming in. If it is a SAML-based application, SAML2-based application, we can intercept the traffic and send it to your reverse proxy, which is built on the next generation firewall, and then send all the traffic through the next generation firewall. So you get all the controls and the capabilities of the firewall, even for a BYOD kind, unmanaged kind of a device.
And sir, second question, when you're designing this, do you look at the user experience from that perspective as well, not just from the technology perspective?
Yes.
Okay.
Yeah, so the clientless VPN, of course, I mean, if you have a browser and you're using it from a user, they don't even know where their traffic is going to. Mm-hmm. It is very, very seamless. And then the SAML proxy, the way it works is the user thinks that they're authenticating to their regular IDP, and the IDP just hands it over. And from a user, it's very, very seamless. As long as it is a browser, I mean, they just think that they're going to a browser and to their app.
Perfect. Thank you.
Yeah.
Right. That's a really good, deep question. Okay. Is that it? All right. Thank you so much.
Thank you.